we have seen different plots for your categorical variables, and now we are going to move on to the numerical variables and create different plots for that. The first one over here is your dot plot. So we are going to write the code that will generate a dot plot for a sample of 30 ages from the data set. So we already have your pandas library and matplotlib. So we will import numpy as well. Import numpy as np because it is used for advanced statistical analysis. And now we are going to sample 30 random ages from the age column in your data frame that was defined earlier also, that is over here data. Okay, so from this data set we are going to extract the age column, and then from that age column we are going to randomly sample 30 ages. So let us write the code for that. So let us define the sample size, sample underscore size as 30, and write sample underscore ages as data age dot sample underscore size, the same variable that we have used over here. And then we also add another argument over here, random state is equal to 42. Okay, so what we are doing basically is that if you look at this portion, so we are basically focusing on your age column in your data frame data, and not this dot sample. This is actually a pandas method that is used to randomly select a specified number of rows from that column. So here, since we have written sample size, and sample size we have fixed as 30, so it means it will randomly sample 30 values from that column. And note that we have written over here random state is equal to 42. So this basically, this random state parameter over here, it is set to 42, or we fix it to some value so that every time you perform this code you will get the same random sample. Okay, otherwise it might get changed. So you can write any other non-negative integer also. So but common convention is to use 42, or you may use 123 also. And if you do not want reproducibility, you can just you can mention this as none. So random state none means that every time you run the code you would get a different random sample. So once you write this, basically this variable over here, this sample ages, will contain a random sample of 30 age values from the column age of the data frame. Now, since there can be repetition in these age values, suppose 25 may appear 3 times and 22 may appear 5 times. So in that case, we want to see how many unique values are there and their corresponding counts. So next we are going to write unique ages, unique underscore ages comma counts is equal to np dot unique. We are calling the numpy library over here, and here we will write sample ages and return counts is equal to true. So here we are basically calling the numpy library to calculate the unique ages from this sample ages, and that will be stored in unique ages and their corresponding counts as well to create the dot plot. So this function basically np dot unique function, this is used to find the unique values within this variable. So it will return an array consisting of all unique age values, and this over here we set at true this parameter, which means that in addition to the unique values also the function is going to return a second array that will contain the count also for each unique value. So basically you will have two variables. One is unique ages. This variable will basically contain an array of unique age values, okay, like 25, 30, 27, 28, like this. And the second variable, that is counts, this would contain an array of counts. So basically it will represent that how many counts are there, or the number of times each unique age value appears in your sample ages. So once this is done, we want to create a dot plot, right? And for creating that, we need to have a list of age values which are repeated according to their respective counts. So in order to create that list, we will just write over here, use list comprehensions to create scatter x and scatter y. So I will explain the meanings of these. So let me just first write scatter x is equal to value for idx, comma, value in enumerate unique ages, unique underscore ages, for in range counts I index over here, and scatter y is basically your I for count in counts for I in range 1 to count plus 1. So what we have done over here, see, since we needed a list of age values repeated according to their respective counts, so we are going to create a list over here. So it will repeat, suppose 25 is coming 3 times, then it will write 25, the count for 25 is 3. From here it means that it will repeat 25 3 times, it will write 25, 25 and 25. So likewise, if 22 is appearing twice, then it will write 22 and 22. So like in that way you will get a list. So this scatter x over here, it will contain list of age values repeated according to their respective counts. So this is a list comprehension which iterates over the unique ages. Okay, this you have already obtained. It will iterate over your unique ages, and for each unique age value it will repeat that value these many number of times. So it will see, as I just said, for instance, if there are 3 individuals who are age 25, then this over here scatter x will contain 3 25s. And if you look at scatter y, so basically it will also contain, it will be list of integers that represent the position along the y-axis for each dot in the dot plot. Okay, so it will go from 1 to the maximum count for any age. So if 25 is appearing 3 times, whereas 22 is appearing suppose 5 times, and all other ages are appearing less than 5, so it will go up till that. Okay, so it will go up to the maximum one. So here let us see what it means. So this is also creating a list comprehension. It will iterate over these counts, and for each count it will generate a sequence of values that will start from 1 to count plus 1. Okay, so note that why we are writing count plus 1, because in Python when we specify a range from start to end, so the end value is always excluded, right? So if you just write count, it means this last value, this count actually will be excluded, and it will go up till count minus 1. So that is why we go up till count plus 1, so that the last one, that is count, is included in this range. Okay, so if range is 1 to 4, it will include only 1 to 3, and 4 will be excluded. So we do not want that. That is why we write count plus 1. So finally, basically here we have list of age values which are repeated according to the respective counts, and scatter y, this is basically the list of integers that represents the position along the y axis. So now let us create this dot plot using the scatter plot plt.scatter. So on we will use this function over here, scatter, yeah, spelling is correct. So scatter underscore x, so this will represent your x coordinates, and scatter underscore y will be your y axis, and we want to use red color suppose for your dots, so we will mention that. And if you want the edges of the dots to be also of black color, we can mention it. And we also set the size of each dot to suppose 50. So it has already given it. So scatter plot, so on x axis you have these, on y axis you have this. Red, you can see these are the dots, edge colors are black, okay, you may change it according to your need, and the size of each dot is 50. So you can alter that. So let me first complete this code over here. So plt dot ytex, it will go from range 1 to max counts plus 1. So again we are writing plus 1 over here, which means that, so here we want the ytex positions to be basically based on the counts of ages. So here you can see it is some randomly coming because we have not written the entire code. So here we want to specify that the y axis tick positions should be based on the count of ages in order to ensure that each group age is represented properly. So here you can see that max counts, first it will see the maximum count value from the counts array. So it will represent the maximum number of dots stacked vertically at any age value, right? So you can see there are 3 dots stacked on this age, and in this case we have 2. So here it will generate, this range will generate a sequence of integers. It will start from 1, that is the y axis over here, it will start from this bottom 1 and it will go up till maximum counts plus 1. So 1 more than the maximum count value, because ultimately it will consider the maximum counts. So now we can just also write the figure, set the figure size, plot dot figure, fix size as 8 by 4. So 8 is the width and 4 is the height. Let us also mention the title of this plot. So we will write dot plot for ages. In the x axis, what should be the label? It will be the age, and in the y axis the label will be count. Now suppose you want to add the grid lines, plt.grid. So let us only add grids for the y axis, not for the x axis, and we want these grids or the lines to be of dashed style. So you can see here we write this, and we set the thickness or the transparency over here as 0.7. So if you want to make it darker, so you can do that, but then the readability will be affected. So I will show you how it is done. So let me just first complete this plot dot show. Finally it will reflect the plot. Okay, so let me just write these two as well. Yes. So the figure size has to be specified first. So what we have done over here, we have specified the size of the figure, then we have written that on the x-axis you should have the ages and y will have the counts. Red, we have specified the red color of the dots, and edges should be black, and size is for 50 over here. And you can see the range is going till 3. It means that the maximum count for any age was 3 from this sample. So it has counted 3 also, and it is using this display is double. You can see the dashed line is there. If I just want a solid line and I rerun this, then basically you can see that this becomes thicker over here, but this doesn't look appropriate, so we would just make this. And if you want to see how the transparency is impacted if we change this value of alpha, so you see this becomes darker, these lines, whereas if you just write 0.5 and then run this, so the dots are more clear, and we want the dots to be obviously have better transparency. Likewise, you can alter the size of the dots also from here. You can make them smaller, and if you do not want the edge colors, right, so here you see that the edges are black. If you want just to be in red, you can simply remove this and rerun this. You can see that the edges are removed now, so we can just keep it as of now. Fine. So this plot, basically this dot plot, gives a visual representation of the distribution of ages in the sample that you have collected. Okay, so you see that the dots over here are stacked one above the other to indicate that how many times this particular age appears in that data set or the sample size, sample that we have extracted over here. Sample size is 30. So you can change this in order to get a sample of, suppose, say 50 or 100, whatever is your demand, and you will get the dot plot accordingly. Suppose I just make this as 100 and rerun all of these. So for this I can just go to kernel and write restart and run all. Okay, so if you do this, what will happen? So all the input statements will be run again. So you can see that star asterisk is coming on top because it is running. Once it is done, you will get finally the output. Now here, if you want, I can change this to 100, and you can see the number of dots over here have increased so much. Now as the number of dots increase, this dot plot gets cluttered and it gets difficult to interpret these. Hence, to deal with this, we instead draw a histogram which divides the ages into different bins or the class intervals, and then look at the corresponding frequencies. So now we are going to write the code for a histogram for the age distribution in your data set. So we already have the libraries, pandas and matplotlib. The data set is already loaded, so we can directly go and create the histogram. So create a histogram. So PLT, so we set the size of the figure. Suppose you wanted for the width is 10 and height is 6 inches. Or we can just write it over here only. So now we are going to use plt.hist function to create the histogram. So what are the parameters over here? Let me just write it. Data, age, so we are focusing on this age column from the data set. Suppose bins are 10, we want 10 bins. Color, let us specify as sky blue, and edge color we can add as black, and we can again write alpha as 0.7. So here we have specified this, that data is basically the age column, and here we want bins of size 10. The color of the bars in the histogram would be sky blue and their edges will be black, and this is to make them slightly transparent. Now we can add the title and the labels. So probably I could just simply use the same thing from here. Okay, so the heading would change. So histogram, we can write histogram for ages, and here you have age. In this side we have frequency on the y-axis, so grid axis y. Okay, and line style and alpha can be same, plot dot show. Fine, so let us display how the graph. So you see, this is your histogram. So using this histogram you can visualize the distribution of ages in your data set. It looks left skewed in this case. So if we change the number of bins, suppose here 20, and run this, so you see how it appears. So basically if you change the number of bins, it affects the granularity of the histogram. So the number of bins will make the plot, if you increase the number of bins, it will also make the plot more granular, and you can see smaller variation in the data, as it was not that evident earlier. However, we should be careful, because using too many bins can also lead to a cluttered plot. Okay, suppose I change this to suppose 30, then you will see how it will look like. Okay, so this will be a very cluttered data set, cluttered histogram. So the choice of the number of bins should be carefully made. So the choice of the bins should be carefully made depending upon the characteristics of your data set, so that you can gain insight from it. Maybe we can take it 15 also. So this was your histogram.